In this video, we're going to talk about extended access lists. What are extended access lists? When would we use them? How would we use them? And then we'll look at an example of actually implementing those in our environments. Now, to start off with extended access lists, let's actually compare those to standard access lists. Standard access lists are pretty simple. Basically, they only look at the source address. So we can only see who's sending some information to me, and then it permits or denies all traffic. There's no, I want this traffic to go through, but not this traffic. It is basically everything from this source is permitted or everything from this source is denied. Now, obviously, that's not the best way to run things. You need to be a little bit more specific of, I want this port to go through, and I want this client to talk to me with these ports, but nobody else, which is where the extended access lists come in. Extended access lists, they check both the source and the destination address. So we can actually say this IP can talk to this IP. It allows, permit, or deny based on ports or applications. Applications come in for things where we don't use ports, such as ICMP or ping. So that's really where it starts coming in. Is we're starting to be able to be more granular with our access list decisions. We can look not just at the source, we can look at the destination as well, or only the destination. And then we can permit or deny based on ports or the various applications in our environment. So let's take a look at an example here. Here we have a sample network with a few networks, a few access lists identified. The first one is that we need to allow this 192.168.3.0 network to access this network. So if this is our server network, then that means that these guys right here should have full access to the server network. So far, so good. That's nice and simple. Second is we need to allow ping from everywhere. So these guys need to be able to ping, these guys need to ping, and these guys need to be able to ping the server network. All right, so far so good. Third line, we need to permit HTTP or port 80 from everywhere. Everywhere down to our web server, which is this guy right here. So all of these guys should be able to contact the web server. And then last but not least, we have a file server that we need to allow FTP from everywhere. Yellow is not the right choice for that. Let's try black. From everywhere to the FTP server. All right, so as we look through all of our rules here, everything that we've just come up with as far as a flow, we can start seeing where all the traffic has things in common. And all the traffic has in common one specific interface on this router, which is E1-3. So E1-3 is probably where we might want to put our rules, and we might want to call it something along the lines of protect servers. My assumption, of course, is that this is our server network, and that is what we're protecting. If it was like a DMZ, we'd call it protect DMZ, blah, blah, blah. Yeah. All right. Well, let's go ahead and take what we've just seen there and let's start putting it into a spreadsheet. So I've got a spreadsheet here of all of our permit denies. When you look at these, some things will be new. If you're used to the standard access list, permit deny and source IP is perfectly normal. However, now we can also start looking at the source port. So we can also look to see what port clients are initiating communications from. Destination IP is new with the extended access list. We couldn't see that before, we couldn't evaluate that before, but now we can. Same thing with the destination port. We can evaluate not just what client or what IP address are you talking to, but also what port on that IP are you talking to. And then lastly, the interface, the direction, and the rule name. So we've pretty much already said that the one interface, E1-3, is going to be our target for most of these rules, and we're also going to call this protect servers. So let's go ahead and look at it. Our first line says allow the 192.168.3.0/24 network full access to the entire 172.31.10/24 network. All right, so we start that off. We have a permit. The source IP is going to be the 192.168.3.0/24. What port do we want to allow? Well, it doesn't say, it actually says we want full access. So we want unrestricted access from whatever application we're on. So I'm actually going to put a star here next to the source port. Star meaning wildcard. Destination 172.31.10/24. Destination port. Again, it's going to be any port that I want to talk to, so I'm just going to put in a wildcard. We'll actually come back to the directions later. The second command, or second requirement, is to allow ping from everywhere to the 172.31.10/24 network. So again, a permit. In this case, the source IP, it's not just 192.168.3 or 192.168.2 or 1. It is everywhere. So I'm going to put in a star for the wildcard. The source port is where things start becoming questionable. Am I doing, and it kind of changes on the fact that we're using ICMP as opposed to TCP or UDP. Normally, when I say a source port, I'm thinking something like 53/TCP. The TCP being Transmission Control Protocol, which is the protocol along with the port. In this case, we want to allow ICMP. So I'm going to type that in there, just knowing that it's not actually a port number, but when we change this to a configuration command, we'll know what to type in there. The destination 172.31.10/24, destination port, wildcard again, and then interface E13 and the same rule name. All right, rule number 3, permit HTTP from everywhere to the web server. So we're going to be pretty much copying what we had done just before that. So permit from everywhere is a wildcard, and then HTTP. Ooh, this is where we have to take a look back at our diagram, and we have to start figuring out how HTTP, what ports are at the source and which ports are at the destination. For instance, let's say that I have this machine right here and he wants to talk to the web server. So it goes like that, and now I have to start figuring out which ports are where. Well, I know port 80 is HTTP. Is that port 80 on the server or port 80 on the client? And it is only on one of those. If you think back to your early networking days, port 80 is actually on the server. So 80 is on the destination. The client side, however, is pretty much going to be anything greater than 1024. Some random port is created on the client side in order to connect to the server side. So that means when we're setting up our firewall rules, the source port is going to be any source port. It's the destination port here under port 80 that we need to start setting our firewall rules for. So in that case, when we're allowing port 80, the source port is going to be a wildcard. The destination IP is specifically for the web server, which is 172.31.111. Is that correct? 11, yes. And the destination port is port 80. Again, everything's going through the same interface. And then lastly, for FTP, so permit, same thing as the HTTP up above that, just different port and different destinations. So the source is everywhere, source port is any, destination 172.31.110, and then the destination port in this case is 21 for FTP, E1/3, and protect servers. So we are pretty much done here with setting everything up. The only correct questions are the directions, and I'm kind of curious about these networks here. First off, let's start off with the direction. If we are setting this up right here on E1/3, the question is, what direction is the traffic going? The traffic is going that way. So from the router's point of view, it is outbound. So our direction is outbound. And then the next question was, with this guy right here, these last two rules here, they actually focus on specific machines, specific IP addresses, so we need those to be in there. However, right here, these two guys focus on the entire network. If we look back at the network diagram, the 172.31.10/24 network is the only network that is on this interface. Therefore, only data that is targeted for that network will go through that interface, and therefore we don't necessarily need to specify the IP address. We should just be able to say anything that is going out of this router or out of this interface is going to apply to this network. Hopefully that makes sense. What that means is we don't actually have to type in a destination IP. We can just simply make it a wildcard. Any traffic coming from 192.168.3.0 going out Ethernet 1.3 will be going to that 172.31.1 network. Therefore, we could just say the IP address. It doesn't really matter what it is at that point. All right, so at that point, we should be ready to get going. So I already have a packet tracer set up. Right there. I've gone ahead, I've IP'd everything out of interest. Let's go ahead and fire up a command prompt. This is PCB, so I can go ahead and ping 192.168.2.10. That goes through. Ping 192.168.3.10, which goes through, and ping 172.31.1.10, and that goes through. So all the clients are IP'd, the router is IP'd, routing is working. To further confirm things are working, I am on PCB. I'm going to open up a web browser and I'm going to browse to the file server, something we don't want to happen. So I'm going to go ahead and type in the IP address 172.31.1.10, and we'll see that the web page pops up. And then conversely, I'm going to FTP to the web server, FTP 172.31.1.11, and we'll see that it connects. So those last two items I specifically did in order to show that they shouldn't be happening. So there is no firewall configurations. It is simply routing is set up and it's ready for us to put our rules on the router. So let's go ahead and get started on that. Go into configuration mode, and we want to create an extended access list. So IP space access, IP dash access, IP space access list, question mark, extended. And then what do we want to call it? I called it protect servers. And now when we look at these rules here, it doesn't really matter what order we put them in. It is all just a bunch of permit statements. At the very end of all these permit statements, there is an implicit deny, which we don't even have to state, so that will automatically block everything that we don't otherwise permit. So I'll just start with the top down. Permit. Again, question mark if you're ever confused. We want to permit, in this case, the protocol is IP. We're not selecting a specific port. We're saying all IP, all TCP, all UDP traffic should be able to go through here. So the protocol is IP. Then asks us for the source address, which is 192.168.3.0 space question mark. Asks us for the wildcard bits. Remember, our wildcard bits are the opposite of the mask. So in this case, our mask is 255.255.255.0, which means our wildcard is 0.0.0.255. 0.0.0.255. Question mark then asks us for our destination. In this case, our destination is in fact a wildcard destination and wildcard ports. So I'm going to choose any. Question mark to see if there's anything more in there. We're not dealing with any precedents or DSCPs, so we can go ahead and hit carriage return or enter. First rule's down, on to the next one. So permit. In this case, we are not allowing TCP, UDP, or IP. We are allowing ICMP. So permit ICMP, question mark. Same thing, the source. In this case, the source is any. It's a wildcard source IP. So I'm going to say any. Question mark. Destination. Again, it's any. So any. Here it then says, well, which type of ICMP do you want? Do you want echo, echo reply, host unreachable, blah, blah, blah? I actually want to allow all of these, so I'm just going to leave it blank and hit enter. On to rule number 3, permit. In this case, we are specifically going to be permitting TCP port 80, which means here we have to specify TCP for the protocol. Question mark for the source. In this case, the source again is anybody wants to be able to communicate with this host, so any. We then talk about the destination address, which is 172.31.111. Oh, excuse me. It's only one specific IP, so we'll want to specify host. So host 172.31, 172.31.111. And then question mark, and this is where it asks us for the ports that we want. And so we can actually say equal or EQ. Question mark. And here we can actually type in the port number we want, such as 80, or it actually knows some of the common ports. So we can type in www, making it a little bit easier for us if we can't really remember what the port numbers are. All right, rule number 3 in place. Lastly, rule number 4 is going to be essentially exactly what we, in fact, you know what? Rule number 4 is so much like rule number 3, I'm not even going to retype it. I'm going to up arrow. I'm going to change the 11 to a 10, and then the equal to FTP, and hit enter. At this point, our implicit deny is already added to the end, so we should be done with our firewall rules. Now we just have to go to our interface, E1-3, apply it in an outbound direction. So int E1-3 is IP access group. I always forget the access list versus access group, so I start typing IP access, hit tab, and it fills out whatever the correct one is for that time. In this case, the rule name is protect servers. Case sensitive. If you get even the slightest typo there, it won't work. And outbound. At this point, everything should be configured. We should be able to test whether it's working or not. So we'll start off first by being here on PC. Let's go on a PCC. Let's go ahead and try to ping 192.168.1.10 just to confirm that it works. And then 3.10. I'm already on the 2 network, so I don't need to ping myself. And then we'll ping something on the server network. 31.1.10. And that works flawlessly. So that was requirement number 1. That was requirement number 2, allowing everything to ping. We'll actually come back to requirement number 1 once we've confirmed that requirements 3 and 4 are taken care of. So requirement number 3 says you should be able to access the web server. What I'm going to do first is I'm going to try to access via HTTP the file server. That should not work. So I'm going to try it anyways. So from the desktop, I'm going to open up the web browser and I'm going to try to browse to 172.1.1.10, which is the file server, and the access list should actually deny. And we can see it is timing out. Yay, my firewall is blocking that traffic. If I change the IP address over to 11, which is our web server, it should now work. All right. Do the same thing from the command line here to access the FTP server. So I'm going to FTP 172.31.1. First off, I'm going to try the web server. So .11. That should time out on me as well. Looks like it is. Yep, timed out. I'll repeat that again for the file server, which connects flawlessly. So looking at my rules, ping seems to be working. HTTP and FTP rules seem to be working. The very last rule, number 1, says that this last network, 192.168.3.0/24, should be able to do those things I just failed at doing. So PCD down there at the very bottom should be able to browse a website on the file server, and it should be able to connect to FTP on the web server. Let's check it out. So if I open up PCD here, first off, we'll ping a couple of things. Ping 172.31.1.10. Sure, that works. And now what failed on the other client, I'm going to FTP to the web server, 172.31.1.11, and it connects right up. So that seems like it's working. Out of confirmation, let's do the same thing with .10. And that one connects as well. So I can FTP to both servers because that one specific network has been identified to allow full access to that website. To that FTP server. Let's try it also with the website. 172.31.1.10, which is the file server. The other clients were not able to access the web service on the file server. If I hit enter, it fires right up. Same thing if I go to .10, this is going to be somewhat anticlimactic because you're not going to see a change since the web contents are the same between the two, but they both opened up. So there we have it. We had 4 requirements, and by creating some extended access lists, just 4 lines in our extended access list, we were able to actually specify who was our source, who was our destinations, what ports those clients can talk to, as well as allowing a management type network be able to have unfettered access to a network while everybody else was highly restricted as far as what they could do. Now, before I close off, this is one way to do it. I'm sure there are a lot of different ways to be able to do this configuration. This is the way that just came to my mind right now. It looks fairly simple. You may actually find something better, more power to you. Yeah.